Okay, so now we're going to do this problem again. First step, eigenstuff. So we've got one eigenvector, or one eigenvalue with 12. The eigenvector is 1, 0, 1. And then the other one is complex. So it's going to be 3 plus 6i is the eigenvalue. And then Wolfram alpha for the eigenvector is given 4 plus 7i, 3 plus 2i, and 13. And since the matrix has real coefficients, the other eigenvector is just, or the other eigenpair is just going to be a complex conjugate of this one. Okay, so remember, how do we do this? The whole reason we split things into eigenvalues and eigenvectors is so we can handle each one. We can handle each eigenvalue independently of the other ones. So the general solution, what are the terms we're going to get? Well, from this one, we're going to get e to the 12t times 1, 0, 1. And what are we going to have over here? Well, we need to look at the real and imaginary parts of this vector. Okay, and that's going to give us two other vectors. Okay, so let's get the real and imaginary parts of this vector. So again, by Euler's formula, this is e to the 3t times cosine 6t plus I sine of 6t times 4, 3, 13 plus I 7, 2, 0. Okay, and so now the real and imaginary parts, e to the 3t. Okay, so it's going to be 4 cosine 6t, 3 cosine 6t, 6t, 13 cosine 6t, then minus 7 sine 6t, minus 2 sine 6t, and then that's a 0, so there's nothing else. And then the imaginary part, I times e to the 3t. Okay, so this will be 7 cosine 6t, and then 2 cosine 6t. Okay, and this is going to be plus 4 sine 6t plus 3 sine 6t, and then this will be 13 sine 6t. Okay, so we split this into its real and imaginary parts, and so the general solution, x1 of t, x2 of t, x3 of t, is going to be equal to the stuff involving the first eigenvalue, so that's a constant times the stuff involving the first eigenvalue, so that's a times e to the 12t, 1, 0, 1, plus b times the real part, which is e. So now this part is for the second eigenvalue, so it's b times e to the 3t, 4 cosine 6t, minus 7 sine 6t, 3 cosine 6t, minus 2 sine 6t, 13 cosine 6t, and now we're going to add c. Now it's going to be the imaginary part, e to the 3t, and we're going to put the imaginary part here, 7 cosine 6t plus 4 sine 6t, 2 cosine 6t plus 3 sine 6t, and then 13 sine 6t, and that is it. But again, I just want to emphasize that the point is that when you're analyzing the part of the solution that goes along with this part, you ignore the part of the solution that goes along with that. That's the whole reason that we split it up using the eigenvalues.